Hello, class. Today we're going to pick up back with Chapter 7. And in Chapter 7, we actually have 7.5 to 7.8 that we need to finish up. And in all of these, we're going to be dealing with how to factor. Now, let me just explain something real quick. If you remember back from 7.4, you were given a problem potentially that might have looked something like this. Okay? We don't know how to solve a typical problem like this. Like before this class, if you were given y plus 7 equals 0, you could easily solve that. If you were given maybe y squared minus 10 equals 0, you could solve that. But it's when you throw this extra variable in there that makes it really difficult. So what we taught you in 7.4 is to pull out the greatest common factor. And so when you look at this, the greatest common factor would be y. And you would pull out the letter, and then you will put what you're left over with. So you're left over with y, so y times y makes y squared. And then if you pull a y out of here, you would be left over with 7. And so this is what we call factored form. You really want parentheses. Getting parentheses is really helpful to solving. And then what you do is you just set each piece equal to 0. So you do y is equal to 0, and then this part right here would be y plus 7 is equal to 0, and then when you move the 7 over, you get negative 7. So those would be your two solutions. Okay, sorry, I was kind of running out of room there. But you really need to create parentheses. Now, what you need to really pay attention to is this right here is a binomial. Do you see how there's only two parts? If you look at today's lesson, we have a trinomial. So all of your problems today are going to be trinomials, and so the procedure has to be a little different. So in these lessons, the remaining lessons that we have left, these 4 lessons, they're going to basically teach you different pieces and how to factor. So every day they're going to kind of change. Do you see this problem right here? They're going to kind of change this up a little bit, okay? So I have 12 problems here that I just kind of want to walk you through. Now, in the first 9, you can see that there is no equal sign. So all we're going to do on these ones is we're going to factor. We're not technically going to solve. Now, if you look at my number 10, you notice really the only thing different between number 10 and like number 7 is that they threw the equals on. So then I just kind of want to show you what to do. This is really just going one step further, but it's not that difficult. All right, so when we go back up here to number 1, if you notice, there is no greatest common factor. So I can't pull the greatest common factor out. So what I have to do here is kind of the reverse of what you did back in 7.2 and 7.3. I have to figure out what two binomials FOIL together, so multiply together to get this back. And so what I do is I look at this and I say, okay, what makes up c squared? Well, that had to have been c times c. And then I look at this and I say, what makes up 7? What multiplies to get 7? Well, there's only one thing that multiplies to get 7, and that's 1 times 7. And now the symbols. The last symbol is really your key. If this last symbol is a plus sign, that tells you whatever goes in these two parentheses must be the same. And how you know what that is you look back right here, and this tells you that they both have to be addition signs. So then we're going to put both a plus sign in each one. And then what I want you to do is I want you to check your outers and your inners. So remember your FOIL, first, outer, inner, last. If we check our outers, c times 7, and if we check our inner, 1 times c, notice how we get 8c, which is the middle term. So now we know we have done this correct. So this is what's called factored form. So whenever you see this word factor, you basically want to create parentheses. That's what you're trying to do, okay? So let's walk through another one here. 8, okay? So we've got d squared, so we know that's going to be d times d. Now 8 is not a prime number. Do you see how 7 was a prime number? The only option to multiply to get 7 was 1 times 7. But now 8. I have two different options for 8. I can either use 1 times 8 or I can use 2 times 4. Now, one little trick we use is we say to ourselves, what multiplies to get 8, that's going to add to get 6. So I can tell you right now that this is not a good combination because it's not going to make me a 6, but 2 and 4 does. Now, it doesn't matter where the 2 and 4 goes. Just like over here, I could have put the 7 first. That doesn't matter. Sometimes what does matter is the symbols inside. So we'll talk about that later. But if you notice again, this symbol is an addition sign. So when I look back, do you see how this one is also an addition? Which tells me then that these both must be plus symbols. And so if I check my outer, so D times 4, and if I check my inner, notice 4 plus 2 gets me my 6. Especially at the beginning, you always want to check your outers and your inners. And you can write them down or you can do them in your head, but you definitely want to check them. Now, on this next one, I want you to notice the symbols. Do you see how the symbols are changing a little bit? So let's try this one. X squared, we know is going to be x times x. 21, again, is a composite number, but we don't have that many options. So it's 1 in 21, or it's 3 times 7. Now again, if I was there with you, I would ask you what the multiples are, but since I'm not, I have to do it myself. Now, which of these combinations is going to get me to a 10? Clearly not this one, so I'm going to have to use 3 times 7. So I go 3 times 7, so I know that's going to give me my 21. Now, again, if you notice, my last symbol is a plus symbol, but look, I have a subtraction now. So what that tells me is that inside my parentheses, both of these need to be a subtraction. Because what's a negative times a negative? A positive. So whenever this last symbol is a plus sign, these will match. What gets tricky is one like this, when the last symbol is not a plus sign. But we'll get there. So let's quick check our outer. That's a negative 7x. And let's check our inner. So that's a negative 3. Negative 7, negative 3. I know I've got the right answer, so I'm all done. Okay? Why don't you try number 4? So if you need to, you can pause the video here. All right, if you've tried it. Now 12 makes it a little bit harder because there's 3 combinations to make up 12. 1 and 12, 2 and 6, 3 and 4. So see how you have a few more choices. But use this middle term to your advantage. The only combination on here that's going to get me to a 7 is going to be 3 and 4. These two combinations don't get me to a 7. So now for s squared, I'm going to use s times s. And then for 12, I'm going to use 3 and 4. And remember, you can put the 4 first. That doesn't make any difference. That's okay. And then once again, if I look at my symbol, because this is an addition, when I look back, that means it's both subtraction. So I know this is a minus and a minus. And then when I check my outer, I have a negative 4s. And when I check my inner, I have a negative 3s. So I know I've done it right. Okay? All right, now let's try one with a subtraction on the end. So with a subtraction on the end, we're still going to start it the same way. So we're going to go y times y, because that's going to get us y squared. Now notice this is a prime number again, so you only have one option. If you want to go 2, 1, that's up to you, okay? But this one, there is a wrong answer per se. Because this is a subtraction sign, when you multiply these together, 2 times 1, the symbols make a difference. For instance, I can't have both subtractions because a negative times a negative would make a positive. I can't have both positives because a positive times a positive doesn't work. So I have to have one of each. So what if I switch this right here to be a minus? Okay? Notice a positive times a negative gets me a negative. So that would be fine. But check your outer and inner. If I do my outer, I get a negative 1y. If I do my inner, I get a positive 2y. A negative 1 plus 2 would be a positive 1. Do I want a positive 1? No, I need a negative. So what I want to do is I want to change these symbols. So I want to make this one the subtraction and this one the addition. Because watch when I do my outers now. This would become a positive 1. This would become a negative 2, which makes a negative 1. So you really got to be careful in this particular situation because the symbols do make a difference. Now, here is another way to write the same answer. Y plus 1 and y minus 2. Do you notice, though, how the subtraction sign belonged with the 2 and the plus sign belonged with the 1? Remember, this is called the commutative property because technically you're multiplying. So the order of the parentheses does not make a difference. What does make a difference is what's inside the parentheses. So please be careful of that and watch for that. All right, notice we have 4 left in this section. So if you would like to pause it here and give it a try on your own, that would be great. All right, hopefully you've paused it and tried it. Let me quick go through the answers here. I've got U and U. And then when I'm looking at 18, I'm thinking that it's going to have to be 6 times 3. And notice this is telling me my signs are going to be alternating, so they're going to be different. And I want the plus to be with the bigger number. This symbol right here, so this tells you that they alternate. This symbol tells you who the bigger one gets. So the 6, the bigger number must get it. And if I check my outer, notice it's a negative 3, and then notice that's a plus 6. So once again, it's a positive. So I know I've got it right. Now this will be the last time I'll do it, but just to kind of show you, you could have written the minus 3 first and the plus 6 second. So as long as the plus and the minus, then you're okay. All right, number 7. I've got Z and Z. Ooh, 56. I got to think about 56. Probably going to be 8 times 7 because that gets me down to a 1. So 8 and 7. And remember, my signs are going to alternate. And this goes with the bigger of the 2. Sorry, kind of off your screen here. There we go. So this is going to be a minus 8 and a plus 7. And I'm just going to quick check. That'll be a 7Z. And that'll be a negative 8Z, so that's a negative 1Z. And so I know I've done it right. All right, 24. I've got H and H. And 24, I'm thinking this is going to be 6 times 4. So 6 times 4. Again, this tells me my signs are going to alternate. And then this right here is going to go with the bigger of the 2. So I'm going to go with the plus 6 and minus 4. And I'm going to check my outer. So that's a negative 4H and a plus 6H, and then I get a 2H. When you're starting these, it might be really, really helpful to use a pencil just so that you can erase. Part of the reason why I'm not using a pencil is you can even see right here, sometimes the pencil with this document camera on the projection is a little harder to see, so that's why I'm kind of trying to use a pen so it's just easier for you to look at. All right, last one here. F and F. Notice when these numbers, as they get bigger, there's more combinations that multiply to get them. Like for instance, I know this is 4 times 10, but 4 plus 10, 10 minus 4 doesn't get me here. So I have to pick the combination that's going to combine to get this 3. So I know it must be 8 times 5, because if I go 8 minus 5, I'll get the 3. So this is going to be an 8 and a 5. And then, oops, sorry, there we go. And then I know that this is going to tell me my signs alternate, and this symbol goes with the larger one. So the negative goes with the 8, and the plus goes with the 5. And if we quick check, that's a positive 5F and a minus 8F. So that gives me a negative 3F. So I know I've done it right. So this is really the heart of factoring. Now, the only thing we have left to do here is they threw the equal sign on you. But if you were to white this out, notice that problem doesn't look any different than the ones above. So what I want you to do is actually kind of ignore this or just kind of keep copying it. So we're going to use our two parentheses and we're just going to put an equal 0 at the tail end. But we're really going to focus on the trinomial here. So to get u squared, we're going to go u times u. And then 10, remember, if you think about what multiplies to get 10, you have 1 and 10 or 2 and 5. But you need that to combine to get the 7. So we know it must be the 2 and 5. So we're going to go with 2 and 5. Now if we look at this last symbol, this tells us that our symbols are the same. And then we look back, they're both subtractions. So remember, when your last symbol, let's grab another sheet, hold on here. When the last symbol, okay, if the last symbol is a plus sign, they're the same. So you'll either get both plus or you'll have both minuses, okay, if your last symbol is a plus. If your last symbol is a subtraction, then they'll alternate. They'll be different. So you'll either have, one plus and one minus or vice versa, okay? So really everything goes based upon this last symbol. That's really the key there, okay? So we know that they're going to be the same and they're both subtractions. Now it wants me to solve. Because it wants me to solve, just like what I showed you up here when we reviewed, all you have to do is set each piece equal to 0. So all I'm going to do is take my parentheses and set them equal to 0. So u minus 2 is equal to 0, u minus 5 is equal to 0, and then if I just move the 2 over, and if I move the 5 over, and I get 2 solutions. Now in the next chapter, we're going to talk more about what these solutions actually mean. So for right now, I just want you to focus on getting the numbers. And then again, chapter 8, we'll talk about what does this actually mean, all right? So if you look at numbers 11 and 12, the only thing different with 11 and 12 is, do you see how they're not equal to 0? Do you see how the number is on that side? So what you have to do in both of these is you have to move the number over to the other side. So if this is a positive 27, we just have to subtract it. So we're going to subtract the 27 and set it equal to 0. So you just need to set them equal to 0, and then you can get your parentheses. So again, if you want to pause the video here and quick try them on your own, that would be great. All right, hopefully you paused it. I'm going to go ahead and factor this one for you. I get g times g, and then 27, I'm thinking that's 9 times 3. And notice my signs are going to alternate, which means the bigger number needs to get the plus and the smaller. And if I quick check my outer, that's a -3 and a +9, so I know I've done it right. So I have g plus 9 equals 0, and g minus 3 equals 0. And then if I subtract the 9, I get -9. And if I add the 3, I get +3. Now some kids might ask, are you always going to get 2 solutions? No, you won't, but for right now, let's just, yes, you are going to. So in today's lesson, you're going to get 2 solutions, but know that it does exist to only get 1 or to be none, but we'll deal with that on another day. So if I move the 30 over, so I'm setting it equal to 0. And again, now I'm going to get my parentheses. So whenever you want to factor or solve, parentheses are your best friend. And then 30, I'm thinking is 5 and 6. I know there's other combinations, but the other combinations aren't going to get me to a 1. So this tells me my signs are going to alternate. So this symbol goes with the bigger of the 2. And again, if you're kind of unsure, just use a pencil. But when you check your outer, notice it's a -6, and then I do my inner, I get a +5, which is a -1. So I know I've done it right. If you don't do it right, you just got to change your symbols. And then you're going to set each one of these equal to 0. And then you're going to subtract the 5. And then you're going to add the 6 to the other side. And you don't always have to get one positive and one negative. So you notice on this first one that we did, do you see how they were both positive? They don't have to alternate signs. They can be the same sign. So don't think there's a trick there. But that is really the heart of factoring a trinomial. And so tomorrow's lesson in 7-6, they're going to put a number out front here. So they're going to make it a little bit more difficult.